So today we will be looking at a program, machine learning program, hospital mortality rate prediction. We will be making this code on Google Colab so that you can also do it along with us. So first of all, we have to understand that it is a classification problem. Let us begin by first importing our libraries. So import pandas as PD, import numpy as NP. With this command we are importing pandas and numpy. Now we have to read our dataset. We will be reading it and storing it in form of a data frame. Here we need to paste our location. For that we need to mount our Google Drive. Once the Google Drive mounting is complete, we can then directly copy our location. See, the mounting has been completed. We will go to Drive, My Drive, search the location where you have saved your folder. So I have saved in AIML programs. Here I have hospital mortality rate and copied this copy path, mortality.csv. I have done the copy path and pasted it. So we see it is successful and the dataset has been read. df.head will show me the top 5 entries of it. Now let us check the info. This will give us an idea of all the features and what type these features are. That can be categorical. If it had been categorical, it would have been written as object. Since it is float, most of them are float. So all the features are numerical types, as we can see from df.info. Now let us check for null values. So we will use the command df.isNull.sum. We can see that we are having some null values here. Now we will deal with them accordingly. So we will replace the missing values by mean, since we are having numerical values. So let us use a for loop. For x in df.columns, so we are getting some suggestions here, but it is better to not use those suggestions when we are doing our code. So df of x dot fill na, df of x dot mean. So whatever the null values, it will go through all the columns, and whatever the null values are there, those null values will be filled by the mean of that column. And in place equal to true means that the change is permanent. Okay, now we will check it. So df.isNull.sum, it should show zeros. Okay, so all the null values has been replaced by the mean values of that respective column. So here we have made one mistake. The dependent variable outcome cannot be replaced by mean. It has to be replaced by the mode value. So we will rectify it. In the for loop df dot columns, we will drop the this outcome variable. We have to specify the axis so that the column is dropped. Now we have to run whole program again. For simplicity, let us there seems to be a spelling mistake. Okay, we have copied and pasted it here. Now we will restart the whole session. See, when you are making the program, you are bound to make mistakes. I have done it in real time, so that is why I ended up making mistake. But then I checked it, I realized it, and then I have rectified it. This is what happens in the real world. See, no one can make it all correct in one attempt, okay? For that you need a lot of practice, and even then you are bound to make some mistakes. So our outcome has a one null value. We will fill it with the mode. Mode is the highest occurring value. We are getting the suggestions from the AI, but still I prefer to write my own code. We will be writing it by our own, means we will be typing it. So df of outcome dot fill na, df of outcome dot mode 0. See, mode 0 is put because there will be many modes, like if there are more modes, means there are two values, then 0 means it will select the first value. Now see, there are no null values, so we have handled the missing values now. We will just have a look at the dataset by using df.head. See, df.head using df.head gives us an idea from time to time, like what exactly is there in our dataset. So now we will be will be starting data pre-processing. Our x will be all the features excluding the target variable, and y will be the target variable. So we will drop outcome from the data frame, that will give me my x, and y will be my df of outcome. Now we have to do scaling of x data frame. See, in machine learning, it is a good practice to first split into test and train. So generally what happens, that we do the calculation on the train data and we apply on the test data. For example, if we are doing the scaling whatever we are doing, we will do the fit and transform on the train data and only transform on the test data. Basically, while calculating the parameters of the scaling, the information from the train dataset should not be used. That is the reason splitting is done first. So x under from sklearn dot model selection import train test split, x underscore test train, x underscore test, y underscore train test is equal to train test split x y test size and random state. From sklearn dot preprocessing import standard scaler. we'll make an instance object sc equal to standard scalar and sc dot fit underscore transform. So we will do the fit and transform on the trained dataset and only transform on the test dataset. We will rename is at x underscore train underscore scaled. And x underscore test underscore scaled. See, now we try to check the first 5 values of the x underscore train underscore scaled, but this is showing me an error. That is because after the scaling has been done, it has been converted to an array. My dataset has been converted to an array. I will have to convert it back to the data frame. So I have to use pd.dataframe and I have to specify the columns. So you have to keep this in mind that after you are applying the scaling transformation, your dataset is converted into an ND array. Okay. We had made one typing error previously, that is why we are facing this error. So we have converted train into data frame and test into data frame. So we got x underscore train underscore final and similarly x underscore test underscore final. We will run the whole program again. Okay, so it is done. Now let us check our training dataset. Okay, so we see that the scaling has been done. Now we want to drop the useless columns. Useless in the sense that they are not contributing to the machine learning, our algorithm. It will not contribute to model training. So x underscore train underscore final dot drop id. We have dropped it in both train and test dataset. Now we will be training the model. We will be using different algorithms to train our model. Okay. So first of all, we will use logistic regression. From sklearn dot linear model import logistic regression. LR equal to logistic regression and LR dot fit. So x underscore train and y underscore train. Now we will make a function so as to evaluate the model. This will make our work a bit easier. Otherwise we will have to write the evaluation commands many times. Each time we are testing it with different model. Okay. So from sklearn.matrix import the accuracy score. Now define one model evaluation. In this we will pass the model as parameter. Y underscore train underscore predict model dot predict x underscore train underscore final. See, this model is very nice, very important, and very convenient. For now I have used the help of AI. You will see this in the next step. So I will calculate the percentage of the difference between the training accuracy and the testing accuracy. This will help me get an idea about the overfitting, whether the model is overfitting or underfitting. I am simply making a code a bit simple. Same thing is happening. I am just storing it in a different variable. Like directly I am not calculating in the print command itself. Okay, because this will be useful for me while calculating the percentage. So the percentage difference will be training accuracy minus test accuracy upon the training accuracy, and this will be multiplied by 100. Now we will print this. Now, and according to whatever comes, we will get a conclusion. Just put a slash in so that it is not in one line. It will come in two different lines when it is printed. So as I said, depending upon the percentage difference, we will decide whether our model is underfitting or overfitting. So if it is greater than 5, then the model is if the percent difference is here, there it seems to be a mistake. The percent difference must be less than 5. So I had written it a bit opposite. I want you guys to correct it in your code when you are writing it. As I told, we are bound to make mistakes. I hope you got the idea here. Now we will see it with the random forest. From sklearn.ensemble import random forest classifier. So rf equal to random forest classifier and rf.fit x train and y train. So we have directly fitted the model. Now we will evaluate it. So we see here that training accuracy is very high, testing accuracy is very low. So there is a difference of 14%. It is too large a difference. That means that the model is overfitting. It is working very good with the training data, but it is not working so good with the testing data. See, when I mentioned previously that I had made a mistake, it was not a mistake, it was correct only. If the difference between the testing and the training accuracy is more than 5%, then the model is overfitting. That is what we had mentioned in the function. So our function is correct. Now we will try it with SVM, support vector machine. From sklearn.svm import svc, support vector classifier. Sv is an object, sv equal to svc, and we will fit our train data. Now we shall evaluate our model. Now you know why we made that function and how that function has made our life so easy. Simply we will put the name of the function, we will call it directly model eval and sv. There is an error here, yes. See again here, training accuracy is 92%, testing accuracy is 84% only. So the model is working very good on training data, but it is not working at all on the testing data. So it is overfitting. It is learning the patterns of the training. It is not a generalized model. So support vector classifier is also giving overfitted model. So that is how we have to keep checking all the models and we have to select which one is the best. So presently among these three things that we have checked, the logistic regression has given us the best result, wherein the difference between the training and testing accuracy was not greater than 5%. So we can say that it was more of a generalized model. I hope you enjoyed the video. We will be concluding it here only. Do let us know in the comments that how you liked the video. Thank you very much. Thank you for watching.